Is everybody ready?
Not yet. Give me a sec.
Okay.
I have a question about SQL actually. Is SQL the only language that allows you to interact with databases, or are there others?
SQL is the only language, however, not the only way. There are databases that also work with what we call NoSQL databases, but there are very few of those. And that's much recent technology. So majority of the database work uses SQL.
Okay.
All right, I'm in now.
Okay. So our first topic for today is about identity columns. Or in some of the other languages, they come out as auto numbers. So these are the columns in which things are generated automatically. So if I were to create a table called invoice data, in which I'm creating a field called sequence number. So this is how I can create a column to be of a certain data type, here integer, auto numbered, not null, generated always as identity. Then I need to provide some details that I will start with 1. It will increment by 1. I do not want it to cycle, means if it reaches, let's say, max of 1,000, I do not want it to go back to 1, okay? And always keep the order. Oh, I forgot to write the keyword by 1. Increment by 1. So in the first approach, I used 3 values: default, ISBN, and cost. In the second approach, I listed the fields that I'm only inserting values in these 2 fields. And then I inserted 2 records at the same time. So when I'm checking, notice the sequence number is in sequence 1, 2, 3. And the rest of the data is the one that I entered. Did everybody get this to work or still working on it?
It worked.
Good morning, Thomas. Thomas, did you just join? Any questions, Jose or Christina? Guys are good?
Yeah, I'm okay.
Okay. How about you, Christina? Good? Okay. Okay, guys. Now, let's say, like in the past, we wrote an SQL query that give me the book title, or let's say book ISBN and book cost of the most expensive book. Okay. You guys remember this kind of a query? How will you
Yes.
solve this query?
I think it's just select select star from books where ISBN equals select IS and then the nested query select ISBN.
Well, we are only to display the ISBN and the book, so we'll select.
Oh no, it'd be ISBN cost from books where cost equals max cost, right?
Cost equals.
Max cost.
Uh-uh.
Oh no, I was okay. So like getting it jumbled up. My bad.
Okay. So we return the maximum cost to the outer query, and wherever that cost matches it will tell us that this ISBN number is the highest costing book, or the most, expensive book in terms of cost. Okay. How will I display all the ISBNs and all the costs in ascending order?
Just select ISBN cost from books ordered by cost.
Okay.
ASC, right?
The
So yeah, if
descending.
it's ascending, you don't need to
Descending, yeah.
specify it.
Descending. Okay. Now this is easy stuff for you guys because we have done it so many times. Now what I'm getting to right now is difficult stuff, and that is, what if you're given the task, give me the second and third most costly books. And it's not like, you will sit there and like, oh, okay, this ISBN number is this and this ISBN number is that, and you hard code that. Because what if the cost changes tomorrow, your query is irrelevant, right? There isn't any built-in function to look at the second or the third. There isn't any built-in function to, let's say, if, this was one of the interview questions many years ago. I think it was an Oracle interview question, that give me the top 5 salespeople. You can tell the highest, you can tell the lowest, you can tell the average, but how about the top 5? So that's something that I want to look at with you guys from a DB2's perspective, where we will learn how you can fetch the second and the third positions. So we will still select ISBN and cost from up till this much. It'll be exactly the same. After that, we will create a temporary table. This can be done with a temporary table. So I'll be creating my temporary table here. Select. I'll write the portion of the select afterward. Okay. Select everything. So I'm creating a temporary column. I'm selecting all the fields and I'm creating a temporary column called row number. And this row number is ordered by cost in the descending order. And this whole column is aliased top cost. And this is part of my temporary table. So when I say ISBN and cost, they are the 2 fields that are coming from the asterisks. Because B dot asterisk mean where B is the alias for books, all the fields in the book, comma, 1 extra field, which is the row numbers. And this row number field is by cost. So the row number of the most expensive will be 1. The row number of the second expensive will be 2. Third expensive will be 3, and so on and so forth. Okay. So from the temporary table, I'm extracting these 2 fields. And now this whole table, temporary table, I'm giving it an alias top 2 and 3. That's the alias name for the table. Now in my where clause, I'm saying where the top cost, which is the column that holds the row number, is between 2 and 3. Means I'm looking at the row number 2 and the row number 3. So these are, and I ordered by cost in ascending order. So that's why it is like this. If I wanted to be in the descending order, then it can be like this. So top, second, and third. Okay, did everybody get to see this?
What is the this field? I mean, is this a function, row underscore
Yep.
number?
Yes, it's a built-in function
Okay.
to give each row a number, and we are numbering it by the cost in descending order because cost is basically what we want to extract things from.
Right.
So this could probably take another twist if somebody says, you know, I want to see the top 3 cost of all the books that cost less than 20. So when you say less than 20, then your temporary table will be whatever your temporary table is based on, the rest of the query will revolve around that. However, this temporary table that we created only works for one SQL statement in which you have created it. It is possible to also create what we call global temporary table, which is the kind of table, so temporary table that works with more than one SQL statements. So that's a global temporary table. So how this global temporary table is created and what are its limitations? Typically, or generally, when you create a table, the table is defined in the DB2 catalog. But global temp table is not defined in the DB2 catalog. Neither it is shareable between users. It only exists within the current thread. And can only be seen by the author or the creator of the global table. This is not permanent, it's temporary, and it has a limited scope. It's at the session level. You know, if you want to understand from web development perspective, it's at the session level. So we declare by using the word declare global temporary table. And then as I told you, it's at the session level. So you'll use the word session dot, and then you'll give it a name. And then you'll define the fields that you want to include in this temporary table. So I'm just going through table creation process, guys.
These global temporary tables are not explained in the book, right?
No,
Okay.
neither was the table above. So what we just did, we created a global temporary table called GTC Books 1 with 3 fields. And we asked the system that we want to preserve the data in it. And of course, that will be preserved only for the duration of the session. Right now, the data is empty. There is no data in it. It's empty. So we can check that by simply typing select star from session.gtcbooks1. And you will see that it has 3 fields, but it has no data in it. Now comes the question, what could be a situation in which you would use such a table? For example, you can see by the field names that I want to store the categories, all the categories, all the book categories. For each category, I want to store its average cost, and I want to store the total number of books in each category. Generally, I would have to write subqueries to do that. And that means a lot of code. And that means every time I run it, I need to run aggregate functions. That is a performance issue. So what I can do is I can create this temporary table. I can move all those aggregate functions results in this temporary table, put this temporary table in the memory, and then whatever queries I need, I can then run it off this temporary table. And in-memory databases are, of course, much faster than on-disk databases. So now we will transfer some data in this. So insert data in the temporary table. Insert into the table so and so. So we need to select category. Oh, because I do have a null category. Okay.
Sorry, can you scroll back up real quick?
Mhm.
Oh, okay. Oh, wait. Back up 1 sec. All right, thank you.
So lines 35 through 39 will insert the data, and line number 41 is where we are checking to make sure that the data is inserted. Got it now, everybody?
Yeah, sorry.
Jose, how about you?
Not finished yet.
Oh, that's fine. Yeah, that's okay.
Typing.
So did everybody understand what we did here?
Well, the commit um, was what's the purpose in this case?
Because this is a temporary table, we want the data to be recorded. That's what the commit command does.
Right. But,
For the tables that go in catalog, they're auto-committed. But global tables are not auto-committed.
So without the commit, you will not be able to.
Yeah,
read
yeah, you
data?
won't be, yes, yes. So that's basically pushing the data to be moved from regular memory to the global temporary tables memory so that it stays as long as the session is active.
If you do a rollback, will it remove it?
The rollback command could adversely affect other items too, which are uncommitted.
Which are uncommitted.
Yeah. Yep.
So the catalog is like a folder or a library?
Catalog is basically, you can say that because
Yeah.
all the schemas are in a database catalog,
All the schemas in the catalog.
in the database catalog.
Can you display what's in the catalog within SQL?
Say that again.
Can you display what's in the catalog?
If you are an administrator, yes, you can then display the schemas in the catalog.
Schema.
Yes, yeah, or you can display the catalogs, right? Yeah, it's more of administrative work than a programmer's work. So in this global temporary table that we created, we based it off of certain fields. Some of them were calculated and some of them were coming directly from the table. It is also possible for you to create a global temporary table as an exact replica of an existing table. And that's what we will look at next. So I will copy the first line and change the table name to 2. Okay. I'm creating a temporary table called GTC Books 2. And I want this to be an exact replica of an existing table. So I can type like and the name of an existing table. So now it will be a replica of books, including all the columns. Okay. And if this temporary name already exists, I'm asking it to be replaced with on commit, preserve rows. Oh, I never created this one. So as you can see right now, it's created with all the fields. Of course, it doesn't have any data in it because we never pushed any data in it. Okay. Okay, so now let me copy this over and we will create another temporary table. And this global temporary table will have only some of the fields of a table, not all the fields. So in that case, you can use an as and you can select this is without any data right now. Now we will insert data from books table. Okay, everybody got this? Jose is still working on this one?
No, I got it.
Oh, you got it. Okay, okay, okay. Guys, with this topic, we will now move on to our next topic, which is stored procedures. I don't know if you guys have heard about stored procedures or no, but stored procedures are programs like procedures that are created, compiled, and then after you compile them, they turn into objects. Once they turn into objects, you can use them to be called directly from within SQL, or you can call them from any of the high-level programs such as RPG or C# or Java or any language that can talk to databases can call these programs. Now comes the next question. Okay, we understood that stored procedure is a procedure. It is callable, it's stored as an object, but what's the point of it? Why do we want a stored procedure? Why do we even need a stored procedure? The idea is that, first of all, SQL is a non-procedural language. SQL does not have any programming constructs. Stored procedures allow SQL to have programming constructs. The advantage of that would be that, let's say, for example, you have 5 different SQL statements to run. If you're writing a high-level program, you would run each one of those 5 instructions from your program to the database engine and back. That means you have 5 different kinds of network traffics running from you to the server and back. That means total of 10. If you put all those 5 statements inside a stored procedure, which is housed on the database server, now you will make one call to the stored procedure on the server. The stored procedure will run all 5 of those instructions for you, and you get one result set back. So network traffic is reduced, performance is improved because now everything works locally versus going back and forth. Plus, once things are created and tested and ready to be used, you are basically reducing your coding time. You don't have to keep testing the code. The code is already created and tested, and also it's reusable, not only by you, but anybody that you can give permission to. So stored procedures can also call other stored procedures. That also can be done. Stored procedures can also receive parameters. They can also return values back. So a lot of the operations for which you want to do a one-on-one, writing a single SQL statement will be enough. But if you have a business process, then you have a choice of writing the entire business process as a stored procedure and just call it, or you would have to write it on your end. Now think about it. If it's the same business process that you're using through several different languages that you're using in your corporation, then you're better off creating a stored procedure and putting the entire business process in that stored procedure and just call it from any of the languages or platforms or applications that you're using it, rather than having to code it for each one of them. So that's what stored procedures are. They are objects in the form of programs that are compiled, ready to be used. So stored procedures are created with the help of a command, create procedure. So just like you create table, you create a procedure. Before we start going the stored procedure route, I want you to create 2 tables. These are the 2 tables that I would like you to create. I mean, I probably may already have this table. And I may also have, yeah, I think I created them already. Yeah, okay. We will be using these two tables in our stored procedures. That's why I'm asking you to create them.
Question.
Mhm.
Oh, yes, I have. So you say stored procedures reside on the server where the database management system is, right?
Mhm.
And are they mainly used for retrieving data from the database?
Anything that you can write
Any-
any kind of SQL instructions in them. Any and all SQL instructions that we have learned this far, anything can go in there. And along with you can combine database, programming constructs. They support if conditions, loops, variables, you know. Typically, you would not run a stored procedure with a create command because create commands are only run once. Generally, they're used for things that are repeatedly used. Okay. Now let's create our very first stored procedure. Create procedure. Let's call this one pass a message. And one more thing about stored procedure, when you're passing parameters into the stored procedure, you can have two kinds of parameters. In parameters are those parameters that are only on the receiving end. And out parameters are those parameters that you are returning back to the caller. Since we don't have any return statements in stored procedure, we use out parameters. In other programming languages, you can only return one variable. But in stored procedures, you can have as many out parameters as you like. So you probably may be returning multiple items back. So we are using a single incoming parameter here. We'll call this one message. We declare and everything is written in the same place. So this could be a good example of creating a stored procedure for inserting data in a database. So you simply make a call to this stored procedure, pass whatever parameters you want to pass to it, and it will take care of all the insert logic for you. So you're saving your programmer the hassle of having to write the insert command. So first you compile and then you call the stored procedure. When you create the stored procedure and when you have called it once, select star from test message table to see that one row is inserted in the table. Did you guys get it? Christina and Jose. Okay. Next, we will learn about an example where we will create two stored procedures. One stored procedure will call another stored procedure and will expect a value back. So how do you return a value back from a stored procedure? You create an out parameter as opposed to an in parameter, or you can have some in parameters and some out parameters. So here I will create procedure, and the name of the procedure is called and I'll have one out parameter called reply. I hate it when the copy paste doesn't work. Shortcuts. I don't know why it does that, but anyway, okay. So that's where I'm using my in parameter. How I can use my out parameter is I can assign a value to a reply. If I assign a value to a reply, at the end of the procedure, that value will be returned back to whoever is the caller of this method. Do you guys remember from the pseudocode days, how do you used to assign values to a variable in pseudocode? Let's say if you have a variable X and you want to assign value 10 to the variable X, how would you write
Just
that in
be-
pseudocode?
X equals 10, right?
No. You need something else besides that. In pseudocode, the ground rule is all instructions start with a
Keyword, I'm just guessing.
say that again, Cameron.
Could it be keyword? They all start with a keyword.
They start with a keyword, which is generally categorized as
A command?
a command. Very good. Okay. So in pseudocode, when you're assigning a value to a variable, X equals to 10, what command would you typically use before that? Because there are some languages that still follow the pseudocode
Set?
rules. Set. Very good. And this procedural language of DB2 is also among those languages that do that. So you will use set. And then you will say reply equals to so this is SQL-PL of DB2. Oracle called its stored procedure language PL/SQL. And DB2 calls it SQL space PL. But the idea is very similar. So go ahead and compile this stored procedure. Don't run it yet because we will be creating another stored procedure which will call this stored procedure. So just create the stored procedure. Always remember, whenever you have a caller and called relationship, the called must be created first, because when you're creating caller and the called is not found, it will error out. And what we're doing as a value of reply will be message inserted successfully followed by the current date. And we have to convert it into a character format, otherwise we can't concatenate. Now let's create the caller method. So we're creating a caller stored procedure, and in the caller stored procedure, we will first of all declare a local variable so that you guys can also learn how to declare a local variable. Again, all instructions start with a command. So the command to declare a local variable is declare. Declare a local variable, and it will be of the same size as reply because it is the variable that will hold the value that we will return from reply. So reply's value will be assigned to log val. How? We will look at that next. Now call another stored procedure. Call, that's a command. And the called, that's the name of the stored procedure. The first parameter is MSG, which is an in parameter. And the second parameter is log val, which is a return value parameter. So at the end of the call, log val will hold the value of reply. Which on the next line, you can then assign to the procedure logs table. So remember, we created two tables right at the beginning of stored procedures. So this will go to the second table. So now we will call the caller method, which will call the called method. And then you will check
So how do you compile the stored procedure when you call it?
what do you mean?
Because you said compile the stored procedure and then call. Yeah.
Yeah. Compile the stored procedure caller and make sure that the called is first created.
Okay,
Then
but
the caller,
you're not using a command to compile the stored procedure. My question is, how are you compiling the stored procedure?
oh, it's simply by running it.
By running it.
Yeah.
Okay.
Yeah. Because again, it's an SQL command.
Right. Then if you want to run it again.
Oh, yeah, I mean, like you can run it for creation, and after you create it, then you can call it any number of times.
Any number of times. Okay.
Yeah.
So you create it once and then just call it.
Yes, you can call it from locally, or you can call it from any of the programming languages. Like you can call it from RPG, you can call it from Java, from C#, any language. Okay. And then please check to make sure that the rows were inserted in each one of these tables.
Yeah, it was.
This is the table we are creating next. Now create a table that will declare one field of type number. So I now want to create a stored procedure that will take several parameters, more than 2 parameters. Some of them will be in and one will be out. So what I want to do is I want to create So once I'm done with creating the stored procedures and running them once to create objects, then I'm calling the stored procedure call underscore sum 3 times. Once with both positive values, once with one negative value, the second time also with one of the two values as a negative value. And anytime I call sum, it will then use the two values that I am passing along with an out parameter RST to make a call to call nums. The call nums job is to receive all three parameters, add the first two into the third one, and then at the end of the procedure, the third one will be available to the call sum because that's the out parameter. And then it uses that out parameter to insert that into numbers underscore table. So 3 calls means 3 successful insert operations will take place. So I'm checking the numbers underscore table to make sure that all 3 rows were inserted successfully.
Yep, that worked.
And these are just simple examples to show you that, we did something similar with characters. Now we are doing it with numbers. Also, you can do calculations that you can return. You can make X number of calls. Anytime you make a call, it will do an activity that you've assigned to it.
It's weird that we can't like calling doesn't directly return something. You have to specify where you want it in the function or in the procedure. You have to specify your out
Right.
your out variable.
Right. Because we don't have return instructions with procedures, because procedures are not functions. Functions are value returning, procedures are not. So that's the only way you can get a value out of the procedure is to make out parameters. That's basically how SQL does it, at least. But that gives you an advantage of having more than one variables returned back to caller. Got it, everybody? This one? This one?
Yep.
Now let's create another table called salary tab. And we will use a bit more calculations in our next stored procedure. And the calculation, the results of the calculation will go in the salary field of the salary tab table. Let's see if you guys can create at least the skeleton of this stored procedure. I've given you the name of the stored procedure and the parameters. Just build the basic skeleton of the stored procedure. Once you're done creating the basic skeleton of the stored procedure, can you guys convert the 3 comments I give you into the code? And when you are done creating the stored procedure, then call the stored procedure with appropriate values, and then check to make sure that the data was inserted in the table salary tab. So this is just a sample code to show you the whole process. 2 parameters. We declare a variable salary. We calculate the salary, which is this hours times rate. And then we put the salary into the table. We compile the stored procedure. Then we call the stored procedure with 2 values, 35 goes in hours and 10.25 goes in rate. And then we display the table to see that it has that one record of salary calculated and stored. Okay, everybody got this? Okay. Now let me copy this whole stored procedure that we just created. Copy that. And let's paste it. We're going to call this one salary process number 2. What we want to do different here is we want to write an if condition for calculations. So we'll write an if condition right here. And that's how you write an if condition. If hours is greater than 40, then, this is how you write if then. We will set salary equals to the first 40 hours times the rate plus the remaining hours times the rate times the times and a half. Otherwise, just the salary equals to hours times rate and if. So that's how you write if else. So after I'm done creating this stored procedure, I am calling it twice with one value over 40 and one value under 40. And then I'm checking to see if it has 2 extra records inserted. Page number 381 in your books show you the syntax for an if condition. If author of the book went very concise with stored procedures in the book because the chapter is mostly RPG along with stored procedures. But on page 381, he shows you the syntax of an if condition along with else, if, and else. So if, else, if, else. He just shows you the whole structure there. So else if is written as one word. And else ifs also have conditions, just like if, just like in other languages. Else is the only one without a condition. And on page number 380, he shows you how you can comment in the stored procedures, how you can declare variables in stored procedures. And if you are declaring a variable and you want to assign it an initial value, then you don't say equals to, you rather use the word default, as you can see in the book on page 380, that you declare, for example, he's declaring a variable quantity to XFR, integer, default 0. So 0 becomes the initial value of quantity to XFR. And then if you're doing a regular assignment after declaration, then you can use the set command to do the regular assignment.
What figure is that?
There is no figure number. It
Ah,
is
okay.
it is past figure 14.2. This
Oh, we're on 14. Okay, that
Yeah,
explains
yeah.
my confusion.
So right past figure 14.2, you will see a column, you'll see a heading called SPL language features.
Yeah, okay. Here.
Yeah, under that you can see the comment, the declaration, the set command, and you will see the if condition right after that under conditional statements heading. Also, towards the bottom of page 381, right past the if condition, you will also see how select cases can be written in stored procedures. So you start out with the word case followed by a variable, and then you have several whens that if the variable equals 123, then do this. If the variable equals 234, then do this. Otherwise, do this. So that's one approach which matches the approach of Java or C#. But if you turn to page number 382, look at the second approach of using the switch case or the cases structure, that you don't mention the variable name in the line of the case like you did in the previous one. You rather have separate cases. In the first case, you're literally saying the variable equals 123. In the second one, you're saying when variable exceeds this amount. And the last case is an else. So you have both choices in stored procedure, either to declare the variable once and only check with values under each one of the whens, or do not mention any variable in the case, and each when will have its own check. So it's called a multi-way if-else equivalent. In other languages like Java and C#, you don't really have an equivalent of if-else in switch case, because in switch case in Java and C# only works with equality operator, but not here. Okay, now let's take a break here, guys, till 10:20. And then when you come back at 10:20, we will work with some more stored procedures. This time, we will be working directly with the tables in the database, as opposed to, like existing tables in the database and the existing records in those tables. So I'll see you guys at 10:20.
All right, see you then.
Resume the recording. Thank you.
Thank you.
So we're creating a stored procedure called copy underscore auth name, and this stored procedure will copy the data from one of the table and will push it into one of the other tables. So we want to declare a local variable, and the job of that local variable will be to fetch the data from the database table. What SQL do I usually write if I were to grab one field from a table? Let's say I want to grab the F name from author. What SQL will I type? I want to select F name from the table author. I want to select F name from the table author, right? This is how I will write it. Now I want the F name to move into that variable V underscore F name. To make that happen, I will use into followed by the name of the variable. So now when the command runs, it will grab the F name and will push it into V underscore F name. But now comes a problem. The problem is there are so many names and I'm not in a loop. So what I'm basically saying is I want you to grab 10 values and push it into one variable, and that'll be an error. We will learn later on how you can process multiple records, but for now, with a single record, we would have to use some kind of a where clause to make sure that I'm only grabbing one author. So I'm only grabbing one author. Once I grab the author, then I will push that author from that variable into one of the other tables that we created today, which is test message. In the test message, I will push author's first name, and then I'll push that name that I grabbed from the database. So then call and test. So you make a call and then you test. Oops. Got it, everybody? Working? Okay. Next, I would like you to create a table. Create this table called book underscore costs with 2 fields. Because our next task will be to create a stored procedure to transfer data from 2 fields from a table called books into the 2 fields of this table called book underscore costs. So we are just maintaining a repository of book and cost. And also we will add one more feature to that stored procedure. We will let the user pass the ISBN number. So instead of hard coding, like we did in the previous example where we hard coded the author, we will let the user pass the ISBN number as a parameter, and then we will use that to grab the title and the cost, and we will push that into the book cost table. So since we are asking user to insert or send in the ISBN number, therefore we need a parameter. BK underscore ISBN is the parameter that will be received by the stored procedure, copy underscore book cost. Okay, now can you convert this comment into code?
Yeah. Which fields?
There are 2 fields, right? In the table book
Guessing.
title and cost.
Oh, okay.
So you
fair.
will declare your variables after, like the variable names will be the same with
Yeah.
a suffix of underscore BK. Okay. Now we need to select the values. So select title, comma cost from books. And remember what we did in the last one? We had to have a where clause with an ISBN number matching the BK underscore ISBN What else do I need to do on line 191? So select the title, the cost. I got to use the into clause because I want to transfer the values into these two variables. Into this variable, comma, this variable, okay? So I'm transferring the values from the two fields to the two variables. The two fields coming from the books table and where the ISBN number matches that ISBN number. And once I grab the values from the table fields into variables, I could then insert that into my book underscore costs table. So we need to compile the stored procedure above, then call it, and then test, and then check the table book underscore costs. So I'm making a couple of calls with two different ISBN numbers, just so that you guys don't have to dig up for these ISBN numbers I'm providing you here. You can use them. You should have the same ones in your database as well. And then we are running, we are checking the book cost table to make sure that two records have been transferred. Okay. Did you guys get to test this? Oscar got it. Christina and Christian. Christina got it. Okay. Thomas got it. Okay. Christian also got it. Okay, cool. In the next stored procedure, we want to work with aggregate functions. So I want to create a stored procedure called the monthly high. So I will declare a variable to store the maximum amount. And I'll have a variable to store a detailed message that I will push into a table. Okay, I will let you guys convert that comment into an SQL code. Should be able to do that now after seeing so many examples. And then we need to set the detail message. Okay, so I wrote my select command where I'm selecting the maximum cost into v_max from books. I've created my detailed message statement, which I'm then adding it to the test message table as a record. Can you guys tell me the mistakes I made on line 209? Purposely made mistakes.
You need to convert the current date in Vmax into character type.
Very good. That's it. And then go ahead and call first compile it and then call it. And once you call, after that, you will select star from test message to make sure that everything that you, and like everything is transferred over into the table. It should have one last entry saying highest dollar on so-and-so date is so much. So once you make a call, your select should do that. So far, all the examples that we did, either I did the example or you guys did partial examples or helped me fix the code. Now I'm giving you an example where I want you to build the entire example yourself. Convert these comments into code. Let me give you the name of the stored procedure also. Comp_nums. Okay. And then you will compile, call, and test. Okay. There we go.
What? Hold on. Oh, okay. Never mind that.
Okay. So the code I put together here, your code may be around the same lines, that I declared a comp nums to receive two in parameters, num1 and num2. Since they're already declared as parameters, I do not need to declare them in the local program. I declared a variable RST, which will hold my result. So I declared that variable. After that, I have an if condition where I'm checking to see if num1 is greater than num2, then RST will be this value. Otherwise, if num1 is less than num2, then RST will be this value. Otherwise, RST will be this value. Then whatever is the value of RST, I insert that into the test message. Then I started running my program. In my program, I made 3 calls. In the first call, I passed both numbers to be the same. In the second call, I made the first number less than second one. In the third call, I made the first one greater than second one. And then I made sure that test message has 3 outputs or 3 inserts, 1 for equal, 1 for less, and 1 for more. Okay, is that what you guys had too? Something similar? Okay. I know you guys are taking system design class with Alan. Did you guys talk about transactions in that class yet?
I don't think so, no.
Okay, okay. In general, when we use the word transaction, it doesn't need to involve money. Transaction can be of a file as well. But the word transaction pretty much means that a series of steps that are all considered to be a single unit of work. That's what a transaction is. And we usually explain it with the help of a money example, that if I transfer some money from one account to another, then one account should lose, the other one should gain the same amount. If anything goes wrong between the whole process, the whole transaction should roll back. So a transaction is a series of steps, and all these steps are considered to be a single unit of work. That's what a transaction is. So transactions typically should have ACID properties. ACID, ACID, which means a transaction should have atomicity. That means if multiple transactions of the same kind are running at the same time in the memory, each transaction should be considered a single unit of work, each one of them, like an atom. Smallest divisible entity is a transaction. Within transaction, you can have several steps. Consistency means that at all times, the transaction should be balanced. If one group loses something, the other group is gaining the same amount. Then there should be an isolation, means each transaction should run independent of the other transactions. And there should be durability, that in case of anything going wrong, you should be able to go back to your earlier state. So we will be creating a stored procedure which will treat the entire stored procedure as atomic. What does that mean? That means if anything goes wrong in the stored procedure, then nothing works. Either everything goes through or nothing goes through. And this could be extremely helpful if you're trying to do several SQL instructions, again, against a data set. And if any one of them fail, you want the entire data set to be rolled back, or all the SQL statements to be rolled back. Otherwise, you will have inconsistent data that you'll be like, okay, make this account lose $200, but the other account never received $200. So $200 are lost. You don't want to do that. So that's why you want those to be done in an atomic sub procedure, versus a non-atomic subprocedure. All the subprocedures that we have created so far are non-atomic. So first of all, I want you all to create a table. I will share with you the table definition. Create this table. So after creating the table, we will first of all create a non-atomic subprocedure, and then we will create an atomic subprocedure so that you can see the difference between the two. So this is how I want to proceed with this. I will create a subprocedure that I will call. In that subprocedure, I will run an insert command. After I run my insert command, I will run another insert command. And between the two insert commands, I will raise an error. I will force an error flag to be raised between the two inserts. So in the case of a non-atomic subprocedure, the first insert will go through, only the second one will fail. In case of the atomic, both will fail. Okay, is everybody following that? Okay. Now, how do we raise an error? Well, basically, I'll share with you the syntax, and then we'll include that in our subprocedure. You call a built-in command called signal. And then you say that I want to signal the following SQL state, and then you provide with some kind of a number, which will be an error flag. So it'll just mean that you want to raise an error, like throw an exception on the fly. Okay, now watch carefully what I just wrote here. I said I want to create a procedure called not atomic procedure. That's just a name, but pay special attention to line 266. I literally said I want to begin a not atomic subprocedure. That means whatever SQL statement runs, it will be independent of all the SQL statements that will run after. Do not consider anything to be tied to each other. Okay. So as I told you guys, that inside this, I will have an insert command. I will raise an error, and I'll have another insert command. The first one is before the error is raised. The second one will be after error is raised. And right in between, I am raising an SQL state. Okay, did everybody get to test this to make sure that the atomic state test has the before error, but does not has the after error? So the first insert went through and the second insert failed. Now, what I would like you guys to do is copy this entire stored procedure. Copy this and then paste this right below. Just change two things. Number one, change the name of the stored procedure. Number two, drop the word not from the line of begin. And now compile it. Everything else will stay the same, exactly the same. Let me change this, sorry, atomic and atomic. Also change your insert commands to say atomic versus not atomic. Atomic before error and atomic after error. Then in the test area, we'll make a call to atomic procedure, and then we will check the table. This time you should see no new data entry. So this pretty much shows you that how you can create atomic procedures. If you have a bunch of commands, for example, in RPG, when you are running multiple operations on the same transaction, then you want to create atomic transaction so that everything goes through or nothing goes through. Okay, so now that you guys are done with atomic, non-atomic, now let's move on to our next topic called cursors. Why do we use cursors? Cursors are used when your select command returns one or more records and you need a placeholder to keep these records while your program reads through the records. So that's what the cursors are used for. They're pretty much like result sets in Java or result set like objects in .NET, where the data is kept while you're reading the data. So that's what cursors are. And I'm pretty sure you guys used cursors in RPG as well, right? Okay. So we will be using cursors in SQL now. So before we start working with cursors, please create the following table. So basically our next step would be that I want to write a stored procedure to copy title of the book whose cost equals 19 to the title books table. So I created this table called move multi-vals. Right now, I'll only be able to move one book. So my first step would be that. So to make this happen, I created a result sets to tell that there'll be a cursor here, which we didn't get to use in our previous stored procedures. So I'll have a result set. And then I'm declaring a variable called value underscore var of size 25. Now I'm going to write my cursor here. Declare cursor 1, cursor 4. So now I'll write my SQL statement that I want to select the title from books where cost equals to 19. So my cursor is fetching this data and holding onto it. Okay. So I got to open the cursor so I can read from it. And then I can fetch from the cursor. Copy value from cursor to value underscore var. Insert the fetched title into the table title books. Should be title books, not titled books. Okay. Everybody get to test this one to make sure that you're able to copy one title from books into the title books table. Now on page number 382, author talks about loops in SQLPL. There are 4 loops. There are 4 kinds of loops in SQLPL. One is just loop, which is used for infinite loops, and you can use leave statement to exit. The other kind of loop is the while loop, which is a precondition while loop. We don't have a post-condition while loop. For post-condition, we use a repeat loop. So that's SQLPL differentiates between while and do while by making the first one while precondition and second one repeat, which is equivalent to do while post-condition. And then we have a for loop, which iterates over a set of rows. So those are the 4 different kinds of loops we have. In our next example, we will use a while loop. Why we will use while loop? Because right now we are only fetching one record. Typically, you declare cursor to fetch multiple records. So to fetch multiple records, you have to use loops. So first of all, please copy the stored procedure that you just created and paste it again. The stored procedure that you just created, paste it again, and call this one move multivals 2. I'm making some changes to the variables that I'm declaring. So I have a title variable set to the size 25. And then I will also declare a counter because I have to run a while loop. So those are my 2 variables, title var and counter variable. In my cursor, I want to select all those books that cost more than $10. So I have like a longer list of items. Okay. I will still open the cursor the way I was opening it before. Let me initialize my counter variable to start at 1. And now I want to fetch from the cursor in loop and only fetch the top three, or first three records rather. First three records. So I'll start out by saying fetch from cursor 1 into the title var. After that, I'll start a loop. Loop while the counter variable is less than equals to 3, do this. Which is insert whatever you have fetched, and then increment counter. And then fetch the next record. And then please make a call to move multivals 2, and then check the title books table to make sure that it has 3 more records than before. Everybody got it? Okay. Can you please now select the stored procedure again, copy it and paste it. Come on. I don't know why all of a sudden this copy paste function stops working. And now change it to 3. Move multi-vals 3. In the move multi-vals 3, I want to try with a repeat loop as opposed to the while loop. So we're going to use the repeat loop. In the repeat loop, you will start with the word repeat on right at the beginning of the loop. And towards the end of the loop, hold on a second, because it's a repeat loop, right? I can make one more change here. I don't need to fetch before I enter the body of the loop because it's a repeat loop. I could fetch it. Oh, come on. Okay. I could fetch right at the beginning of the body of the loop. Because the condition is getting checked towards the end, right? So I can fetch the very first record, insert the record, increment the loop counter, and then I can write here my repeat until the counter variable exceeds 3 and repeat. Okay. So I have to reverse the condition because it's a post condition reverse logic loop. Because what repeat until does, it keeps looping as long as the condition is false. As soon as the condition becomes true, it terminates. So what it does here is that it starts out with 1, fetches the record, inserts it, increments it, but since the condition is false, but since the condition is false, then it goes back and fetches the next record and keeps doing it till the condition becomes true, and then it terminates. And then there's one more thing I should do here. Close the cursor 1 right here. And then go ahead and call it and test it. Did you guys get it? Okay. So far, we have only moved limited number of records using while loop or repeat until loop. Next, what I want to do is I want to keep looping until all the records are moved. So for that, let's copy, we already had it copied, so I'm going to just paste it again. No, I don't have it copied. Let me copy it again. Let me copy this, val3, and paste it, and change the name to val4. Move multi vals 4. So I will be using a cursor for loop in this example. The cursor for loop is a very, very powerful cursor because cursor for loop, unlike the while and the repeat, doesn't need a counter variable. It starts and it automatically ends when it is done. So also you don't need to open it. It opens by itself. You do not need to close it. It closes by itself when it is done. So as a result, we'll be removing some of the lines, like we do not need the counter variable, for example. Okay, so that's gone. Now, the cursor declaration will now be different. So we're saying before we start working with declaring the cursor, we don't even need to declare a cursor ahead of time. The cursor will be declared as the body of the cursor for loop. So we will also be changing that to for a variable of a for loop as cursor1, cursor for, and then this is the statement that goes. Okay, no need to use semicolon to stop. The whole structure will automatically stop with and for, just like that. So this is the structure that we will create that will do everything for us. So it will automatically stop when we run out of records. So now the body of the cursor for loop starts out with the word do. Do this. Do what? Set the title variable equals to the title field that's coming from line number 412. And then insert that into title books as values. And then you can delete the rest of the code that you have down below. Everything else will be deleted. So that's what's left. That's all. Cursor for loop will take care of all the steps for you. Okay, did you guys test to make sure that it is working? Christina and Christian. Christian, did you get it too?
Oh, yeah, I did.
Yeah, okay. Okay. Next, I would like you to create this table. Which we will use for our next stored procedure. Oops. Book information. Our next stored procedure will also be using a cursor for loop. So the basic structure is very similar. So using cursor for loop, fetch title of the book and last name, the author of the book. Into book information table. Now using the move multivals for example, let's see if you guys can do this yourself. I'm gonna give you a few minutes to work on it. Let's say till 11:45, and then I will share with you a possible solution.
How do I see what error it generated?
It's giving you an error.
Yeah, when I'm compiling the procedure.
What is the error? It does tells you the error message, right?
No, it just says it's not created. The compile was not successful. That says something in QSys PRT print, but
Can you share your screen?
sure. Am I sharing the right screen?
Yeah. I'm just looking at
Okay.
it. Yeah. Oh, if you look at your number 4, if you scroll up to number 4, can you scroll up to number 4? Okay.
Yeah, number 4.
Now
number
notice,
4 works.
right? But notice, we are assigning the value from the field to the variable in the set under do. You did it right in the for loop.
Is that not possible in this?
No.
Okay, that's fine then.
Yeah. Oh, yeah.
Do I have to do
Equals to title.
that?
Yeah.
Okay.
Enter and then okay, and get rid of the into part.
Yep.
Okay, and see if that works. Okay.
Yep, that worked.
Yeah.
Oh.
Can you scroll up? Yeah, move multi-vals. We call it vals 5. And down below, you're calling without the S, I think. Scroll down.
What line?
The name of your stored procedure is with, oh no, you are calling, okay. It is vals 5, okay. Call move multi-vals 5. Oh, hold on a second. It is complaining that in your stored procedure, title is not found as a column.
I have a feeling it should be this or something.
Scroll up a little bit. And then no. Yeah, that's fine. Yeah, that's fine. Yeah, okay.
Yep, that works.
Yeah, here you go. Okay, cool. Yeah.
Okay. It wants to use the column name, not the qualified name for it.
Right.
And I selected the wrong table. Yep.
Okay, cool. And I will show you guys an alternate approach to that one, which is even easier than that, because in this approach, you still have to use extra variables. The next approach that I'm sharing with you, can you see my screen? Yes. Okay. Notice I did not use any extra variables. Rather, I directly use the field names from the table in the insert. You can also do that. Got it? So guys, that brings us to the end of today's class. You have a new assignment that is posted on the Blackboard, which is assignment number 7 on stored procedures. That's something that you will be working with during the week. And if you haven't completed the quiz, you have a quiz to work on as well. So those are the 2 items for this week. And as I said earlier today, that next class will be our last in-class meeting before the finals. So I will be giving you your final exam at the end of next class. And then you'll have 2 weeks to do it because the week after is a long weekend. Okay, then. That's all for today. Let me